So I've been gone for a few days of Advent Code, and the reason for that is I'm a professor full time. Not shockingly, given the name. Imagine a lot of people watching are students of mine, and just final exam, getting the final exam scanned in for grading, grading the final exam, grading final projects, just everything sort of piling up. So I got just bogged down and wanted to just get through all of that before I jump back into Advent of Code. I needed sleep at night too. I mean, staying up past midnight is always tricky, and once we get into these longer problems, you know. Anyway, okay, so day 13. Just to touch on this, I was an idiot. This was very much a two equations, two variables problem. Um, just straight up two equations, two variables. There's a little bit of a red herring here, where it's the cheapest way to win. Um, which is true, but it's also the only way to win because it's, you know, basically this is 94 times A, where A is the number of A presses, plus 34 times, or sorry, 94 times A plus 22 times B equals this. And once I got it down to two equations, two variables, it's actually really easy. Um, it's really easy at that point. It's just solve two equations, two variables. Simple solution here. If this file will run, there we go. And you can see, I mean, the solve time is very fast, and that's just because just doing some basic matrix math here. Um, that's it. So um, this little bit is to check if the value produces exactly the right number. Just because we're doing long division, which is effectively integer division. So yeah, got the right answer there. Fun problem, but yeah, it's just two equations, two variables, and somehow I just whiffed on that. Anyway, now I have not looked at any of. I have not remotely looked at it. I'm not going to look at the stats. I haven't looked at this website since since day 13, since I got it done. So I'm going to jump to day 14. So let's jump into it. Let's get my no spoilers in chat, please, of any kind. And let me close these, and I'm gonna go to day 14 main. I'm gonna open up my input and test input as I usually do. Um, okay, and let's jump into it. So this looks like my test input. So I'm gonna go ahead and paste that there. And okay, let me go ahead and get my puzzle input. Here we go. All right, so it looks like we're dealing with some kind of coordinate system. Sorry, my thing just vibrated on my watch here. All right. But yeah, just getting final grades and everything out, just it's mildly soul crushing if I'm completely honest. I don't actually enjoy doing it at all. But I have to yeah, I have to do my job. Okay. What is going on here? I haven't actually really been paying too much attention to the historian story because I figured that, like, okay, we're looking for the historian. Everything's really just a way to reference sort of a past problem. This is a fun problem, by the way. 2016 day two. The I don't want to spoil the part two of it, but this is a fun problem. I enjoyed it. Okay. So to get oh, we found the historian. One of the historians needs to use the bathroom, or we found one of them. Oh, I guess we haven't found the senior historian yet. Whatever. You know, there's a bathroom. Blah blah blah. Unfortunately, blah blah blah. Improved. Okay. You need to make a list. All right, so to get the historian safely to the bathroom, you'll need a way to predict where the robots will be in the future. Fortunately, they all seem to They all seem to be moving on the tile floor in predictable straight lines. Each robot's position. Okay, so each of these is a different robot. So we have class robot, data class robot. And this is, I'm going to shrink this down here so I can actually see the text. So it is the position. Oops. Not trying to do that. So it is int. Let me check my input. Okay, yeah, that's all ints. Okay. So it's going to be val px int val py int val vx int val vy int velocity. Okay. So position and velocity. Each robot is, yep, X represents the number of tiles the robot is from the left wall, and Y represents the number from the top wall. Okay, so it's grid position. So position of P00 means that they're in the top left corner. Each robot's velocity is given by blah, and it's tiles per second. So positive X means they're moving right, positive Y means they're moving down. Okay, that's consistent. The robots outside the actual bathroom are in a space which is 101 tiles wide and 103 tiles tall. However, in this example, the robots are in a, okay, so val test width equal test width equals 11 val and const val width equals 103. No. Const val height equals 103. Okay. So the robots outside bathroom are in a space which is 101 wide. Okay. Robots are good at navigating over under each other. So they share the same tile, they don't interact. Visually, the number of robots can look like this. These robots have a unique feature. For maximum bathroom security, they can teleport. When a robot would run into the edge of the space they're in, they instead teleport to the other side, effectively wrapping around. Okay. So it's just a mod operation. Got it. So, so let's do fun move. And now it's actually bar, I just realized. And it's going to be px plus equals vx. Vy plus equals vy, and then I have to handle wraparound. So if px less than 0, not px equals 0, it's px plus equals, and for now I'll do test width, else or not else if, just if. And this will be mod No, because I can end up with weird negative mods, right? Well, that's fine, I think. So let's try robot val r robot equals robot, and it's going to be 2, 4, 2, -3. And we're just going to do, okay, after 1 second, after 2 seconds, after 3 seconds, after 4 seconds. Okay, so repeat 5 times. We're going to robot move, print line, robot. Let's just try this and see what happens. Okay, so we get 4, 1. Wait, that's index 4, 1? What? Oh, 2, 4. Oh, okay, I'm not printing beforehand. Right, right, right. Okay, 2, 4, and then the next one is PX is 4, 1. Okay, that's right. And then it's 6, 9. 1, 2, 3, 4, 5, 6. 1, 2, or sorry, 0, 1, 2, 3, 4, 5. That's not right. 0, 1, 2, 3, 4, 5, 6. That's not right. Oh. Okay, 4, 1. Yep. 6, 5. Okay, that's accurate. Because that's 6x 1, 0, 1, 2, 3, 4, 5y. 0, 1, 2, 3, 4, 5, 6, 7, 8, 2. Yep. 10, 6. Yep. But then I'm getting 12, 3, and that's not right. How am I getting 12, 3 when the width is not? How am I getting 12, 3 on the last one? It's 10, 6, like I get that. The 3 is right. How am I getting 12? How am I going 2 to the right and it not saying? Yeah, we're Vx is 2. So like we add 2 and it's 12. Oh, wait. I'm doing the mod operation out of order. Right. Okay. Yeah, 6 isn't right. That would be because I'm doing. Okay, there we go. Our robots are now behaving nicely. Okay, so we have the robots moving nicely. Story can't wait much longer, so you don't have time to simulate robots very long. Where will the robots be after 100 seconds? Area. Count the number of robots in each quadrant. Robots that are exactly in the middle don't count as being in any quadrant. In this example, the quadrants contain 1, 3, and 4. Okay, all right. So I can get, yeah, I can handle this. So let's do, first, let's just simulate for 100 seconds. That part's easy. First, I need to parse my input. So let me widen this again. So parsing the input is easy enough. It's just, okay, 4 lines in, it's going to be dot map, and we're going to map to robot, and it's it dot substring after t equals dot substring before comma dot toInt. And then it's substring after comma, but before space toInt. And then substring after v equals, and I can even do space v equals here just for more precision. Before comma toInt, and then it's dot substring after last comma. I love Kotlin Standard Library. I don't know if I've mentioned this, but it's really nice. Print line. Okay, there we go. Gotcha, gotcha, gotcha. All right. Now we have our robots, and we're going to simulate for 100 seconds. And I'm guessing what I'm going to have to do is figure out cycles. This is going to be like an LCM problem in the second half, I bet. So for each one, it's just going to be okay. So I need to go exactly after 100 seconds elapsed. So I'm just going to do repeat, and this is going to be seconds. So I'm going to repeat seconds, and I'm just going to do robots dot for each it dot move. And then, so I've now moved the robots 100 seconds, and I'm actually going to do two lists. And I'm going to send a copy of robots rather than the copy, because I imagine I might need to start from 0 on the next part. So robots dot for each it dot move. And then, okay, so I need to break it into quadrants. So in this part, it's going to be, so what was it? For test width, it's, yeah, 5. So it's, um, 0, int range, 0, 5, int range, going to be width divided by 2, and then it's going to be 0, 1, 2, 3, 4, and then plus 1, int range, width divided by 2 plus 1, width. And for now, I'll do test width. For x range in Why is it not like that? And then for Y range in, and it's going to be very similar, list of 0 to test height. Yep. It's going to be val safety scores equal mutable list of int. And then it's just going to be robots dot count, and it's going to be are they in a range? So it's going to be count and let me make sure int ranges and inclusive. Oh, okay. So I don't want it to be inclusive. r.px in x range and r.py in y range. Safety scores dot sum. That didn't work. Okay. I'm gonna make sure nothing is sort of spiraling off into space. Okay, all of these positions are there. Oh, I'm not. Okay, I'm getting 33, but I actually. That's wrong. One. Very wrong. Oh, I did an or. I should get 8 first, or 9 first and foremost, and then I need to change this into a product rather than a sum. Okay, and then dot reduce int and I might want a long here. Just to be safe. To long and change that into long. Just to be safe. We're past day 5. Just assume everything's a long. Okay. That's working. So now, rather than change all of the constants, I'm just going to do it this way. Okay, that's a big number. But it's right. All right. Someone notices that these robots seem awfully similar to ones built. If they're the same type, they should have a hard-coded Easter egg. Very rarely, most of the robots should arrange themselves into a picture of a Christmas tree. Okay. So now it's just going to be get grid. So first we're going to do get robots. What is the fewest number of seconds to display the Easter egg? Okay, so I'm going to create this method. No, I'm going to create this method. And it's going to be, actually, let's change this to print grid robots. And actually, I'm going to do this not here, but here. And I'm going to pass in S. Seconds elapsed int. Okay. So, and actually, technically it's S plus 1. No, it's before they move. Okay, it's actually before they move. So it is in fact S. And then I'm just going to do for I in 0 dot dot test width j in 0 dot test height. Going to be robots dot count r dot px equals I and r dot py equals j. And we're going to print, not print line, print. Then print line here, and then print line seconds elapsed plus $sign seconds elapsed. And then just to make it a bit easier to read, we're going to do print line and then let me make sure I take out any other print statements. Yeah, let's remove that. Okay. Now we're just looking for a Christmas tree. Actually, let's do it this way. I'm going to add a thing where it's if count equals 0, print base, else print. Let's try this. All right, we're just working our way up. Okay, we're looking for all of them to form a Christmas tree. I don't know how else to judge this. Hmm. Hi, Chloe. What are we up to? 31? Hang on, we're getting close. Right? This looks close, right? Wait, is it more than 100? Well, how am I supposed to... Let me hop down. Hmm. Hmm. Okay, they're all sort of lined up in the middle here, interestingly. Okay, so it's going to potentially be a lot more than 100. This is an interesting little speed problem. Um, hmm. Let's do it this way. Let's do... I'm trying to figure out like what maybe is the best way to approach this with my code. And it might just be to do okay, so first I'm actually going to pass in this list of robots, and then for part 2, I'm going to pass in the robots and 100, which is my starting second. Um, but then I'm just going to do this. No, that wasn't what I did. I'm just going to do this. And my rat Chloe, calm down, kid. And my rationale is let's see if I can track like 200 milliseconds. And now I don't need to print here. If it's like it may end up being some like ungodly number, but let's do like that many. I know that's going to take way too long, but the point is, let's go. All right, let's just try it. No, that's too fast for me to track. Thread.sleep. Let's try 400. And what happens is when I see a oh, when I see a Christmas tree, I'll just hit Control C. I have no idea how long this will take. If I don't see something in a bit, what I'll do is I'll just Control C and I'll look for where I'm seeing near coalescence, like a point where they're nearly matching each other, and then I will try to do some type of LCM type stuff. Because I've seen a couple of times where a lot of them have been close together. Maybe I saw something up there. Okay, I'm going to stop here because this is taking a while. But what I'm noticing is like here I have a lot of things in the same column. And that's at 100 plus 352. So that is at, oops, sorry. That is at 452. And I noticed there is another one up here where they were all sort of close together in a column. Yeah. Okay. These are all close together in a row. So I'm going to keep these numbers separate. 302. Let me see if there's any other hints. Okay, let's do print grid, and then this is going to be and I'm still going to print the grid here, but let me also add that thread.sleep in place. And the reason is I'm going to look for sort of the first two instances where I kind of see this pattern emerge. And then I'm going to see if I can do something with that information. Okay. So the first instance of this was at 40 seconds. That was after 40 moves. And that's the vertical alignment. Right. That's that one. Not sure if I missed the horizontal alignment just now. Okay, here was a horizontal alignment. That's at 99. Did I see anything at 80? Nothing interesting at 80. Okay. Because what I need is I need the gaps between these. And I'm looking for just the point where they intersect. All right, that was 40. There's probably some clever way to do this, but oh crap. In hindsight, I want to make it print the numbers. Oh, okay, what was that number? That was 143. No, that's vertical. Excuse me. Wait. So 103. Oh wait, what am I? Duh, duh, duh. Because, and this is important, I'm an idiot, right? 103. Of course, that's how long it takes to wrap around horizontally, which means at time t equals 200 is when I will get. So let's do if s mod 103 equals 40. Right, and we don't need this safety score anymore. Let's just not even bother with part 2. And let's do like that. We'll just do here. Okay, so here's the plan. We're gonna crash. Exactly right. Mm-hmm. Oh, I don't need the thread.sleep anymore. Not there anyway. And the other thing is I'm gonna do right. You can see we're getting kind of this nice like vertical sort of alignment here. Things seem fairly tight vertically. And if I do the same thing with or s mod 101 equals 99, You can see like I'm either getting something horizontal or I'm getting something vertical, right? And so now I just need the number where these two match. All right, let's find the number where these two match. So it would be a number that is, let's see, I need a number that is both nine. I'm trying to think how I would do this. So I'll just change this to an and that might end up being a really, really big number, but who knows? Oh, no, it's not. Small number. There we go. Yep. Haha, we figured it out. 8280. There we go. Figured out the gimmick. All right, day 14 in the books. Let me change this back to, right, I'm going to do this, and it's going to be, part one result is robots dot map it dot copy to list, and then it's just going to be robots um hero um but oh, did it print? Yeah, it did print. Yep. And there's my Christmas tree. All right. Part two, day 14, part one and part two done. Okay. What did it not think? Yeah. Okay. And then let's actually just change this to okay. Now we can push. All right. That's day 14. Let's head on to day 15. All right. Day 15. Yeah, that's just part of this that I knew to sort of check the divisor. And in hindsight, I should have picked up that it was, mod 103, mod 101 faster. But it's just I sort of noticed that clustering, and I knew that you'd obviously have to be clustered to get the Christmas tree. So yeah, it kind of makes sense. Um, so yeah, in hindsight, I think it's because it's all in a quadrant. You could probably check the safety score. That's probably intended for you to be able to figure that out. But anyway, okay. Um, day 15 inputs, day 15 code. All right. So first, let's just. This is our test input. Okay. Wow, that is a big test input, which makes me scared about what my actual input will be. Oops. Okay. So, right, okay. You appear back inside your mini submarine. Each historian drive. Blah blah blah. Let's see if at school with a lanternfish swimming past you. Closer inspection, they seem quite anxious because lanternfish populations grow rapidly. They need a lot of food, and that food needs to be stored somewhere. That's where these lanternfish have built elaborate warehouse complexes operated by robots. Lanternfish seem so anxious because they lost control. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of them are brave enough to swim up. Fail as boxes are shifted around, making actual movement of these robots difficult to predict. Okay, hang on. The robot, so that's attempts to move. If there are any boxes in the way, the robot will also attempt to push boxes. However, if this action would cause to move into a wall, nothing moves. Okay, so the box sliding puzzle. Here is a small example to get started. Okay, let's try this. So new, so we'll bubble up. We'll bubble up to bigger things as we go. Small, and my small test.txt is this. All right, so the basic is I'm going to have grid. So standard val grid equals lines dot sublist up to lines dot first in. Is there like a index of first? Its dot is it dot trim dot is empty. Let me just make sure that's working first. Yes, okay. And then it's dot map to car array So we're going to map each line to a mutable list. So it's dot line dot to car array dot to mutable list dot to mutable list. And then we're going to wrap this in a grid constructor. Right. Okay, now val robot start equals grid dot coordinates dot single line robot start. Yep. Okay. And oh, I just realized I actually want that to be 0. Right. Okay. So now, okay, so we move the boxes around, but what are we doing? Do I need to track the boxes or equal to 100 times its distance from the top edge? Okay, so it's the index of the box. Okay. Right. I can handle that. So now it's going to be and then val directions equals lines dot sublist from index lines dot index first plus 1. And I think I can just do can I not just do sublist until okay. Lines dot size dot join to string that directions. Okay, good. Now hang on, let's do right. Okay, now I just need to map those directions to um, dot map when it up cardinal direction dot down. That's not right, that's left. Cardinal direction dot right. Okay. no. Oh, wait, return. Right, okay. So now we're just going to do for grid robot start directions. And I'm going to do grid dot set. Well, that shouldn't be an issue. Actually, yeah, I know what I want to do. I want to do grid dot set dot start to empty. And there's a reason I'm doing that. Because when I print the grid, unresolved reference grid coordinate, I'm okay. What? It's right there. Unresolved reference grid coordinate. Okay, I don't know why it's not importing those. Okay. So we're gonna say actually no, I'll leave that as is. I'll handle that. So for direction in directions, and I'm first just get the robot moving. So if um so val to move equals grid dot it's going to be dot get movement direction if to move if grid dot get to move equals empty, then we're going to and then let's do unswap grid char. It's going to be coordinate A and chord B. So we're going to swap them. And that's just going to say, okay, grid grid dot set val temp equals grid dot set chord A to grid dot get chord B and grid dot set chord B temp. So we'll just swap grid to move and it's going to be Not what I meant to do. Not at all what I meant to do. Var robot position equals robot start, and we're actually going to do robot position and robot position. Okay, so first, let's do that. And then we're just going to do print line. So for now, let's just try this and just see that we're moving. Right? So okay, so we move left, nothing happens. We move up, nothing happens. Oh, sorry, it's not empty, it's, and let me go ahead and do, okay, so it's going to be const val empty period const val box equals const val wall equals pound. Okay. So we're not going to be moving boxes here, but okay, so we do move left, we don't go anywhere, move up, then we don't move right because we don't know how to push boxes yet. And then we keep moving right, and then we move down eventually. Which we apparently never do. Cardinal direction down, okay. Here, let's do print line. Okay, so we're not moving down correctly. Why aren't we moving down? We're saying down, right? Row 3, column 2? Wait. Hang on. So robot start position. Left is row 2, column 1. Correct. Oh, but I'm not updating the robot's position. Right. Okay, so we go left, doesn't work. We go up, works. We go up, doesn't work. We go right. It doesn't work because we don't know how to do that yet. It goes right, we don't know how to do that yet. We go down. Okay, down. Yes. Left. Yes. Down, down. Okay, cool. So now, um, what I'm gonna do is I'm gonna try this. To move is box and push box to move direction. I'm going to make a Boolean function here. And I'm going to initially make it return true. It'll make sense why in a second, but it's going to be, then we're going to do just the same thing. So for now, this is going to return true. And this is going to behave weird, but that's fine. Right, we swap with the box, keep going, we swap with the box, which is not what we want to do. We want to push the box, but this is where we get into, okay, can I push the box? And the answer is if next space equals, and this is box coordinate and push direction. If, so we're going to have val next space equals box coordinate dot get movement in the push direction. And if the next space is equal to empty, then we return true. Or if grid dot, I need a passing grid, don't I? If grid dot get next space equals empty, then we're going to return true. But before we do that, we're going to swap the grid space in the next box coordinate. So this will help us do that. And then for now, let's just say return false. Okay? So I should be able to push the first box, but not the second. Oh, wait. So I should be able to push the first box, but not two boxes. Okay, so I pushed the first box, but I can't push two boxes, which is fine because now I have a trick. And the trick is, since I have this nice little function here, I can make it recursive. Else, if, and it's going to be push box, and it's going to be next space, or a grid next space, same direction. So try to push that box. Then I do the same thing. Swap and return true. And that didn't work. Index out of bounds. Oh, wait. I know what I did wrong. Not else if anything. It's very specifically else if. So if it's a wall, I don't want to recurse, but grid.get next space equals box. If it's a box and we can push that box, then push this box. And did I get where I wanted to go? Yes, I did. Boom. Yeah, so I'm just recursing. The point is the box itself is pushing the box. And the if if it's not empty or if it's not a wall, so if it's a wall, basically is the else case, then I return false. If at some point I hit a wall, I return false. And the point is, if that box can't move, the box pushing that box can't move, the box pushing that box can't move, which means the robot pushing that box can't move. The aristocrats. So now, after we're done, we're now going to get the box score, which is and it's just going to be grid.coordinates.filter it grid.get it equals not empty but box dot and is it sum or is it the distance is blah blah blah, so the sum of all box GPS coordinates, so it's the dot sum of it dot row times 100 plus it dot call, and we return that. Let's try that on our test input. And let's take out our print statement. Actually, let's leave in our print statement for now. Actually, let's do it this way. Let's still print the grid. We'll print the end state to make sure our end state is right. Checking our end state here against our example. This looks correct. Does, good, okay. And our output is 10,019. Okay, so that's right. So now we can just run input. Oh, let me take out all these print statements here. This might need to be a long. Let me just instinct kicked in here. Let's turn this into a long. And we'll do just okay, it doesn't need to be a long. Okay, that's the right answer. The lanternfish use your information to find a safe moment to swim in and turn off the malfunction robot. Just as they start preparing, a festival in your honor reports are coming in that a second warehouse's robot is okay. This warehouse's layout is surprisingly similar when you just help. There's one key difference. Everything except the robot is twice as wide. You get to the wider warehouses map. Okay. I don't think my algorithm changes, though. I don't think my algorithm changes. Oh, wait. Oh, no, never mind. It does change. This right here sucks. This right here sucks. because it's pushing up here doesn't work. And so now I have to do this tree problem. Hi, kitten. Do you need pets right meow? I don't know if I want to do this yet. I think I need to warm up a bit more to get into this one, or at least start with this. Let me put this one on pause because I'm already forming an idea of how to do it, but it's just I don't want to write the code for it right now. It's a lot. I'm basically just gonna redo everything from scratch. I'm not gonna bother really trying to make. I'm not gonna really bother trying to make my existing code work with this because it's just the logic fundamentally changes so much. And so what I can do is I can do something like um, so val part2 grid equals grid dot coordinates, and it's going to be, I'm going to map each coordinate so let's do it this way, grid dot dot coordinates dot for each. So for each coordinate, so I'm going to map each coordinate to its value. And it's going to be grid dot row indices. Yeah, for each row, I'm going to do and it's going to be dot map column index. I'm going to map each column to when grid dot get coordinate row index column index. If it is period, I'm going to map it to period. If it is box, I'm going to map it to wall. If it is that, I'm going to map it to this. And at, I'm going to map it to at period. Okay, and then it's going to be, so I map each column index to that, and then it's going to be join to string, then dot to car array, dot to mutable list, dot to mutable list grid. Print line, part 2 grid. Okay, and this is the larger example. Wait, the larger from before. Okay, yeah. Let's just try this. I'm surprised this when doesn't count as an expression. Okay, so now I have, okay, so that's right. All right. So now let's do new small part 2 fast. Okay. So now the logic is the same. It's just that I have to apply the same thing to both halves of the box. So I'm going to want some of like on get other box half. And it's going to be grid it's going to be box half grid coordinate and now it's just going to be if grid.get box half equals um equals that, then return box half dot get movement right, get movement left, else throw illegal arguments. Okay. So now I can get the other box half. Okay, so the logic is the same, but now it's um part 2 grid and val part 2 robot start equals part 2 grid dot same logic, right? And so it is part 2 grid, part 2 robot start, and directions again. So logic is fundamentally similar, but there's an important distinction. and it is that I'm gonna have to change how I do push box. So right, I can start with the same logic. Right, I can do this, but why is it not like this? Also make that along, right? But, and this is the key, is that now, if it's equal to box, push box part 2 needs to be created. And the push box part 2 is still grid box half so this is in box halves. Then but now the trick here is going to be I'm going to have to do something special with if direction dot left and if direction dot right. So first, val other box half equals get other box half. And it's going to be if direction equals right. If I'm pushing to the right, I have to check the right box half first. Um, if grid dot get I think this is correct. So we figure out which box half we are. Because if the direction is to the right, we're pushing right, then what we want to do is we first want to do um, if right half dot get movement or cardinal direction dot right, then is empty. Oh, if grid dot get. Actually, this will be val to move equals that. If to move is empty, then okay, we just move. We swap We swap right half and to move, and then we swap grid left half to move as well. No, not to move, excuse me. Swap left half with right half. And then we return true. Okay? And at that point, we return true, right? We swap, we're good. Else if, and I don't actually need to check too many cases. It would be else if grid dot get to move equals or in box halves. Then I would just try to call box half on to move. Which point then we can move. Same movement pattern. Okay. So, and then for now, let's do return false. Okay. If direction, so that's if direction is right, and if direction is left, we just swap this. So if direction is left, then to move is direction dot left. If to move is empty, then we swap the left half with to move, and then we swap the right half with left half. Technically, I don't need to change this line, but I am just to keep things sort of consistent for me. So if we swap the left half, turn true, else is in that, then we repeat, but again, we do left half. And I know that I could probably shorten this code. It would probably be what? Just an or statement here. An or statement and wrap that in an if, but okay, now we handle else. So else if direction dot is left. Else, then we know direction is up or down. At this point, we need to check if both left and right are empty. So actually, there's an easier way to handle this, which is just if grid dot get box half equals period, then return true. If grid dot get box half is pound, then return false. Right, and now does that work? Let me think. I think that does work. And now it's just with B. Oh, but no, wait, I need to see if I can move it. This is the part that sucks, okay? This is the part that sucks. And this was what I was worried about, was this. Because right now I have a method that I don't check if I can move. I move and then check if I moved effectively. And the problem with this approach is that this is true and this is false. And so the way I currently have it set up, this would move, but then this wouldn't. Like here, I can show you what I was thinking, which would be else, and it's, you know, um, if it would be if push box grid box it'd be box it'd be left half direction and push box right direction. Like this was the mindset that I had, and it would be swap left half with left half dot get movement direction swap right half. This was the idea I had in mind, but there's a problem. And I can point out what's going to happen is these two boxes are going to separate when they shouldn't. Um, as we'll see. So to print line. Oh wait, what? What? Left. I get left not working. Why is down not working? I'm confused as to why down's not working. What? Print line, robot position. Hyphen to move. Why am I not moving down? Like I can get there's a bug not moving left. I'm confused why I can't move down. So if I so right, it's empty. Empty, right? But then it's not moving. Why is it not moving? Why is my swap not working? I'm confused why swap's not working. Is something happening where it's swapping back? Let's do. Okay, so we move down. So it's empty. Okay, I'm confused now. Let's see. Okay, so we confirmed that where we're moving to is empty, right? And then we swap empty and robot position. So we print empty, we swap. Hang on, I realize I'm now printing this in a weird spot. So let's do up here. Change the order. So left. I don't, left, I have something going on. Cool, I'll figure that out. Right is, okay, so I do down, and then the spot is empty, but then I don't move down. Why am I not swapping? Num calls. Fourteen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Print line, grid. Why is it not swapping? Grid.set coordinate A equal to the value at coordinate B. Hang on, am I? Oh. Yep. Okay, that was the bug. All right. Index out of bounds get. Somehow I'm trying to get that here. What? How am I? Oh, yes, I see. Okay, we have problems, as we can see. We do in fact have difficulties. right? But I can now take out these print statements that are everywhere, make my code a bit easier to read. Um, okay, so let's try running it. And oh yeah, I need to. And it's going to be print line grid. So after each step, I'm going to print the grid. Let's do print line direction. Okay, so now we do left. And left, we didn't do anything. Okay, so let's look at what happens if we're going to the right. We want to check if we can move the right half right, but we're going to the left. Okay, if left, if the grid left is empty, do that. Otherwise, if the grid, and actually let's do it this way. If the grid left is here's the problem. So that didn't work. Try this. Oh, it's not to move though. It's if I can move the right half and if I can move the left half. Okay. So if it's empty, okay, so first let's just check print line, box half, and then we're gonna do left half, left half, and right half. Okay, so we don't even get this far. How is that? Print line, direction, box in direction, direction. So hang on, we're not even hitting this. Oh, because we're not hitting the true case. But wait a minute. Okay, we're hitting. All right, there we go. Okay, we are getting to it here. And then we're saying the left half and the right half. Okay, that's fine. Yep, left half, right half. We're identifying those correctly. And then if the direction is right, which it's not, so we're not going there. If the direction is left, we're saying get the left half. Okay, so val print line to move. Okay. Yes, that's accurate. And of course, it's not empty, but it is pushed left. Okay. So we're not pushing left. Somehow this is returning false, if we're even calling it. Oh. Right. Wait, no. Yeah, then so if we're moving left, then we want to look left of the left half. And so to move is 3-7. And 3-7 is this. Yet somehow we're not recursing right. Oh, because push box part 2. Yep. The same damn thing. Same damn problem. Which, by the way, this is not going to solve my problem. Because there was one problem that I'm looking for. I'm now hitting. Let me take out my print lines. And I'm running out of space here. Okay. So I'm looking to the left. Oh, right. To move. To move left direction and val to move right direction. If I can push. I know. I get it. Okay. Problem is that I'm gonna have to separate out because I like here's the problem. It is here. So I have the right logic, except when I hit up, you can see that now moves, which I don't want it to move. So I have to separate this logic out of can it move and then actually moving it. I need something like fun can push box part 2, and this is where I'm going to run into having to separate out when I can do something versus actually doing it. And I'm going to do the same logic. But here I think I can just actually keep recursing um until I hit. Yeah, I can actually do this. Whoa. What the? Why is Control Z deleting code? Okay. And it's going to be start direction, and all I'm going to do is just and what I'm doing here is going to be very inefficient. I can tell you this right now. I'm just getting it to work first. So start while true if start if grid.getPos equals empty, then return true. If grid.getPos equals wall, then return false. And then pos equals pos dot get movement direction. Now this is inefficient. I want to be clear. And now it's going to be, because what I'm going to do is I'm going to move this in here. And then it's going to be can move grid to move direction. And this is going to be and I know my code is ugly. I want to be clear. I know my code's ugly. I'm making it work first. If I can move, and then it's same idea here. Although even this won't work. I just realized. I just realized even this won't work. I'm going to run into a problem. Yep. If that is the right, then I'm going to do so now it's actually no longer, now it's a recursive function. And if it's the left, I'm going to, or if it's the right, I'm going to turn can move grid. Well, if it's the light and grid or and direction equals cardinal direction dot up, or actually I can do it this way. If direction dot left or direction equals cardinal direction dot right. First, if these conditions apply, then I can just do return can move and just keep moving in that direction. But if it's left or right and I run into a box, yeah, so actually I can just do if it's left or right, then I can just return not pause dot direction, but pause dot get movement direction. That part's easy. So now this is my else case of if it's left or right. So now I do grid dot get position um, equals or so this is just my else case. Else, and it's going to be val other box half equals get other box half grid position, and then it's going to be return can move other box half dot get direction, so move up or down from the other box half, and I know this is the worst looking logic in the world, but did it work? Okay. So now, for these large boxes, this is measured by the edge of the map, the closest edge of the box in question. So it's always going to be the left side. Yeah, so now it's just going to be return. Oh, 618. Now let's try this one. Ooh, okay. Getting some kind of infinite recursion here. Where did I run into an infinite recursion? Right. Okay. So clearly pushing two boxes to the right, I run into some kind of infinite recursion. Let's figure out why that happens. So if direction is right, to move is right half. Dot get movement to the right. If grid is empty, swap swap, return true. If grid dot to move left, and I can move right. Where specifically am I? If position is empty. Wait, how am I? Okay, so do I not move the right half first? Yeah. So pushing left doesn't cause any problems, but pushing right does. Why? What am I doing different? Why didn't I run into issues pushing left? I didn't have any issues when I was pushing boxes left. Now I'm suddenly having issues when I'm pushing boxes right. Well, somewhere I'm still printing. Okay, here I pushed a box right, and it wasn't a problem. And here I pushed a box in left, and it wasn't a problem. Okay, let's see what's going on here. I pushed some boxes left, right? Correct? Yes, I did. I pushed some boxes left. Okay. Boxes were pushed left. Okay, and I took out that print statement. What happens when I push right? Okay, so now instead of going up that last time, let's go left, up, right. Okay, so pushing right is the problem. So I'm doing something just wrong with pushing to the right. with how I'm recursing, pushing to the right. Here's the difference. Right. Okay, I see. 2 move, and so this needs to also be 2 move. Okay, problem solved. Now, at least that problem solved. I don't know if there's other problems. We'll find out. Now we can do test input. And I know this code is ass. I want to be incredibly clear. This is the most ass code I have ever asked. I have asked this code up like nothing you can imagine. But might work. Let's see if that's right. Okay. I'm going to put this code in a box called do not open. J15 part 1 and 2 working, but the worst code I ever wrote ever in part 2. That's one where what I would do is, now that I understand the challenges of the problem, I would rewrite it from scratch. I would not attempt to salvage this code. I would throw it away and start over for part 2. Just completely throw it away and start over. Because like one of the issues that I have, and I can tell you that this is why it was a bit slow, is that I'm recursing every step along the way multiple times, rather than just going up and down is what I should be able to do. But I don't do that. And so, you know, worst code I ever wrote ever, but it works. What day are we on? Events. 16, 17. All right. WV is about to kick off a bowl game. So I'm not going to even try to do 18 tonight. I'm not even trying to walk through my code for 15. That was just bad. But in fairness, there's actually some legitimate difficulty there, but I still need to I can clean that up now that I sort of understand the problem better. But I pretty much would have to write from scratch. WV is about to kick off a bowl game like in a few seconds. So I'll kill this, and then tomorrow I'll try 16, 17, and 18, and then hopefully I'll be caught up. Knock on wood. Depends on how many regrades I get, things like that. Anyway, take care.